Well, good morning or good afternoon, depending on where you're located. It's Martin here from SLCan. I just wanted to welcome you and thank you for joining today's SLCan webinar presentation on the Living Building Challenge and ACT addressing laboratory buildings holistically. I'm pleased to introduce Alison Paradise, the CEO and founder of My Green Lab. Under her leadership, My Green Lab has established itself as a pioneer in laboratory sustainability. The organization developed the first nationally recognized standard for laboratory operations, established the first Energy Star category for laboratory equipment, and released the first eco-label for laboratory products. Alison regularly speaks at industry meetings and scientific conferences. She holds degrees in neuroscience from Brown and Harvard. I'd also like to introduce James Connolly, the Vice President of Product and Strategic Growth at the International Living Future Institute. James leads the Institute's strategic consulting for corporations and conducts technical consulting for high-profile living building challenge projects both in the U.S. and internationally. Prior to joining the Institute, James received a Fulbright Fellowship to conduct research on green building rating systems in China. He's a frequent speaker on regenerative design, sustainable business, ecological manufacturing, and affordable housing. James is an avid writer, and he has been featured in news outlets such as China Dialogue, TrimTap, Building Green, Green Biz, and Engineering News Record. I would just remind the participants that, as usual, we would just ask if you have any questions during the presentation that you just simply type them in the questions dialog box on your go-to screen, and we will certainly review all of those at the end of the presentation. And without further ado, I will turn this over to James, and welcome, James.
All right, well, thank you, everyone. Looking forward to having this conversation, and I imagine introducing most of you to my organization, which does some work in the laboratory space and hoping to do more, as well as in the healthcare space. But I imagine it might be new to most of you. So looking forward to having this discussion today. So I work for an organization called the International Living Future Institute. Overall, what our mission is to catalyze the transformation towards communities that are socially just, culturally rich, and ecologically restorative. And so our focus is on creating ecologically restorative communities, but social equity and cultural richness is another key part of our mission. And really what we're trying to do is find ways in which humanity can exist in harmony with the natural world, and then demonstrate that principle through actual projects on the ground. And so our best known program, and what I'm going to talk to you about today, is the Living Building Challenge. And it's a green building certification. You can think of it much like LEED, but really pushing the market out at the very, very front end, trying to demonstrate that you can do something possible that people previously didn't think was possible, which was design a building that actually functions like nature. So it is a green building certification, and there are laboratory projects that participate in it, but all number of buildings and types can pursue Living Building Challenge. And we like to think of the program through the metaphor of a flower. So our buildings function like a flower, meaning they harvest all their energy and water on site. They're adapted to climate and site. So a Living Building Challenge project here in Seattle is going to look dramatically different than a Living Building Challenge project in Phoenix, just like a Douglas fir tree would look dramatically different than a cactus in the desert. They operate pollution-free, they're comprised of integrated systems, and lastly, they're beautiful. And we think beauty is a critical aspect of sustainability, because unless a building is beautiful and functional for its users, it's not really going to last. And it's not, maybe more importantly, going to point to a new way to do design and construction that actually works better. The program is divided into 7 petals or performance areas. So the certification addresses place and siting of the building, water, the rain that falls on the building is actually used inside the building in the natural water cycle. Obviously, sorry, I'll keep moving forward here. Energy, ensuring that the building generates all its own energy from the sun. We have a big focus on health and happiness of the people inside the building, as well as materials. And that's actually where there's a lot of overlap with what Allison is going to talk about in a few minutes, the ACT label. And then we also address two issues that are not commonly addressed in green building rating systems: equity, ensuring that you're treating the community equitably, and beauty, as I mentioned previously. Those petals are then broken down into imperatives. You can kind of think of the petals like categories, and the imperatives like points or credits, if you're familiar with other green building rating systems. Another key aspect of our program is that the results are measured through actual performance rather than modeled or anticipated. And most green building rating systems are based upon how you think the building is going to perform based upon design, and living building challenges based upon how it actually performs. And the difference between our program and many other green building rating systems is it's really pushing the market much further, as I mentioned at the beginning. So most green building rating systems are thinking about creating a project that's 30% more energy efficient, 40% more energy efficient. What we're trying to do with the Living Building Challenge is actually create a building that generates more energy than it uses. Applied to health, living buildings are not only a little less likely to cause asthma or other illnesses for the occupants, they actually support human health, productivity, cognitive function, etc. And I'm going to talk about that a little bit after Allison, how buildings can actually influence the performance of the occupants through their design. And what we call that building, or that type of design, is moving beyond sustainable to actually becoming regenerative, giving more than you take over the life cycle of the building. And what we like to think about with the Living Building Challenge is it's not simply just a green building, it's fundamentally just a better building, a better space for occupants to be in. And we think that's critical. You shouldn't have to sacrifice to be in a green building. It actually should be a better space, and a space that people want to be inside. And what we see, a lot of the driving growth of the Living Building Challenge right now is that occupants, whether they're commercial office workers, higher education institution employees, schools, etc., are really driving the adoption of green building standards because they're resulting in better spaces for people to be in. I want to talk about one aspect of the Living Building Challenge here. You know, when we started the program in 2006, I think we thought that energy and water was going to be the most difficult aspect, becoming net zero energy or becoming net zero water. It turns out actually that meeting the materials requirements has been the most difficult aspect of the program. And one critical difficult aspect about that is our red list. Buildings are comprised, or building products rather, are comprised of a lot of toxic chemicals that have significant impact to human and environmental health. And our program has a list of 22 worst-in-class toxic chemicals that are not allowed to be used within a living building. That's created, so when we launched that program, and we think fundamentally buildings should be built free of these worst-in-class red list chemicals. When we launched the program, there's a big disconnect, however. It was really hard to find products that actually met those red list requirements. So when I started at the Institute in 2012, I launched a new program called Declare, which was a tool to connect manufacturers to project teams, and also a tool to drive adoption of transparency within the building product marketplace. That tool is called Declare. And what it's really saying is that we should know information about the products that we put in our buildings that we know are impacting our health every day, just like we should know information about the food we buy. And so the label is literally, or you can think of it similar to a food label, but for building product ingredients. It's asking manufacturers to disclose their ingredients, remove any toxic chemicals, And then that provides this really effective communication tool to architects, designers, building owners, facility managers to find products that they can be ensured aren't going to impact human and environmental health. Since the launch of the program, it's grown massively. We now have over 827 active labels all around the world, and it's really sort of a movement that's caught on in the building product industry. In fact, the Declare label goes beyond just the Living Building Challenge to address requirements in LEED, as well as in the International WELL Building Institute requirement. And, you know, it's quite interesting if you look at the health requirements within LEED and the WELL Building Standard, many of them have been adopted from the Living Building Challenge program. So when we launched the Living Building Challenge in 2006, a lot of the feedback we got from the market was it's too hard, it's not possible, and you know, or it's too expensive, too difficult to implement. And I'm excited to report to you guys that the program is really starting to scale. You're looking at just the sampling of projects now, and our first projects, many of them were environmental learning centers, things like that. We now have many, many large university campus buildings. This is a project at Williams College. We have major projects at Georgia Tech and at ASU, etc. The project in the upper right is a 750,000 square foot project, Microsoft's new Silicon Valley campus. The bottom left is Google's project in Chicago. We're actually now doing their headquarters project in Mountain View, which is a 1 million square foot project. And the one on the bottom right is a retail project in Australia. It's a 350,000 square foot project. So what's been truly exciting for us is showing that we can break into new markets and sort of new scales and new complexities of projects. And I will have to say the healthcare and laboratory space is one of the most complex and most interesting project types. And we do have a few lab projects that are registered and pursuing the challenge, and we're very interested in exploring how we can scale up in that industry, as Allison is going to describe to you, especially because the massive environmental impact that building typology tends to have. So we now have over 700 projects registered all around the world, stretching from nearly every different building type. As I said, we have many projects growing in Europe. Australia and New Zealand have been a big growth area, but we are focused mostly in North America. And we have over 103 certified projects right now. ILFI has also launched new pathways to certify under the Living Building Challenge program, kind of recognizing that not every building can be all the way to net zero energy and net zero water. So we also have pedal certification if you meet one of the challenging pedals, that is water, energy, or materials. We have a zero energy certification if you're just interested in pursuing the energy requirements of Living Building Challenge. And actually we have 2 labs that are registered under that zero energy certification right now. And then we have a zero carbon certification, which is a really entry level for Living Building Challenge certification, or ILFI certifications rather. What this says is the building has to simply perform best in class in terms of energy efficiency, and then you have to purchase a high quality renewable energy offset to offset the impact of that project. So we're talking to many corporations now, including Salesforce, about scaling that across their entire global portfolio, as well as university systems, and a manufacturer called Kingspan, which is one of the world's largest building product manufacturers, to scale it not just for their office spaces, but actually looking at their manufacturing facilities. So we have many different entry points, and the last one I want to mention is a program that we launched in May at Living Future called Core Green Building Certification. This program essentially boils green building down to what are the 10 most important things you need to do if you're going to have a truly green building. That's called Core Green Building Certification, and we think that's a great entry point for people that can't quite get all the way to Living Building Challenge. So with that, I'm going to hand it over to Allison, and I think maybe I want to mention one thing. What the Living Building Challenge does is address the physical infrastructure of a laboratory space or a building in the life sciences industry. And the partnership that we're very excited about with My Green Lab is as she addresses the throughput and what's actually happening inside the building. So with that, I'm going to hand it over to Allison.
Thank you. Okay.
I'm going to try. I figured this out before. Got it. Okay.
Yes. Brilliant. Thank you. Okay. Let me see if I can work out how to make this into full screen for everybody. There we go. Wonderful. Thank you, James. I'm very excited to pick up where James left off because he did a great job of really teeing up the next part of this conversation. So as you can see in my slides here, which I have to say are not nearly as beautiful as James's slides, and we've got to figure out a way to, I think, to hire your designer because they are so beautiful. You can see here that historically I think in pretty much every industry, but particularly in the laboratory space, what we've seen is that there are programs and projects that address the building, shown here on the left, and then there are programs and projects that address working with the scientists. And what we're so excited to announce here on this webinar, and also just in general to share with you, is that our relationship between the International Living Future Institute and My Green Lab really helps to bridge that gap. Because the reality is there is no reason for there to be a gap there between the two. And the fact that there is means that there's so much disconnect between how laboratory buildings are thought of and designed and how scientists actually want to operate their space and how scientists understand their space. I think a really great example of this comes with fume hoods. So oftentimes we'll go into buildings that have been designed with many fume hoods for a space where the scientists actually don't require them for their research. But they wouldn't know to necessarily say that they don't actually need fume hoods because they're used to seeing labs that have fume hoods. So these types of conversations often don't happen, and this is where that bridge can become very, very valuable. So you can see here, this is our goal. For those of you not familiar with My Green Lab, we are a 501c3 nonprofit based in California, and our mission is to build a culture of sustainability through science. So as I mentioned, we work with scientists, we work with people who are actually occupying the building space to help them reduce their environmental impact. We tend to look at 4 key areas: disposal, energy, water, and chemical use. And the reason we do this is because laboratory buildings, I think we all know on this call, are of course incredibly energy intensive spaces, and perhaps you're all familiar with the fact that they're incredibly water intensive. They also produce a tremendous amount of waste. It was estimated that laboratories discard about 12 billion pounds of plastic waste worldwide. This was taken from a study published in Nature a few years ago. Our estimates put this as actually a low number. We think it's actually quite a bit higher than this, which is unbelievable to imagine. If you think about an area the size of Manhattan, imagine that area. Now multiply it by 23 times the size of Manhattan, ankle deep in plastic. Every year, that's at least what laboratories are throwing away. And of course, this doesn't include the gloves. It doesn't include any of the packaging material, any of the hazardous waste. So you can see almost immediately that while the building infrastructure itself has a tremendous environmental impact, the operations of these buildings does too. When it comes to energy, I think we all know how much that laboratories, the statistic laboratory buildings 5 to 10 times more energy than office spaces. If you look to see where that's coming from, you can see a sizable percentage here is due to plug loads. So about 20 to 25% is actually due to laboratory equipment. And this is something that scientists have some level of control over, whether it be what they purchase or how they operate their existing equipment. The same is true, you can see here, for water. So if we look to see where the water usage is coming from, and apologies, I didn't label every single slice of this pie, about 25% of it comes from laboratory processes, which is, again, something that the scientists themselves have some control over. If this were the way that the buildings had to operate in order for us to do research, then okay, then that's what it has to be. Because, of course, principally these buildings have to function in order to support the research that's going on. But the truth is, it really doesn't have to be this way. And we know this from our work, and we know this, I think, from speaking to scientists. So our initial reaction to learning all of this and to talking to scientists was to say, we should develop a certification for scientists on how to better operate their space, which we did. And I'm going to touch on this briefly, just so that we can round out the conversation and the parallels between ILFI and my Green Lab. We do have a Green Lab certification that looks at, you can see here, the topics covered are quite varied, energy, water, waste, of course, being the main topics, but broken down into very fine details, such as waste is broken down into recycling, waste reduction, hazardous waste, and green chemistry, for example. And what this certification does is really educate scientists on best practices and how to operate their space, their building, their science, and do their science in a way that is as responsible as possible. That certification was something we launched about 5 years ago. We now have over 400 laboratory groups certified, and I say laboratory groups because in academia, a laboratory is defined differently than in a biotech company, where a biotech company might define a laboratory space by a drug development group, for example. An academic lab would be the space under one principal investigator. So because of that, we say laboratory groups instead of laboratories. But in essence, we've reached over 20,000 scientists with this program so far. So it's quite robust. And one of the things we kept hearing from scientists was, look, it's really great that we can go through this process and understand that we shouldn't be overriding occupancy sensors just because we find the lights annoying, that they're turning off too quickly, that we can work with facilities to address that. And we recognize now that we can turn off equipment, for example, and we now have recycling bins set up to be able to divert our waste appropriately. But what do we purchase? How do we know what is the most sustainable pair of gloves? And when we were speaking to people who were designing buildings, they wanted to know, how do I know which fume hoods to purchase? How do I know which biosafety cabinets to purchase? Which freezers? Which of these are the most sustainable? So we were looking at the laboratory space and realizing that there are a lot of materials that are in this space that are not necessarily covered by some of these other, for example, LEED certifications or the WELL certification. So we saw this opportunity to establish a consistent, transparent, third-party verified procedure for identifying the environmental impacts of the products that are purchased in the lab, whether these are products that are purchased by the people designing the space or whether these are products that are purchased by the scientists themselves. If you're familiar with our work, you'll know that we've done quite a bit of work here in the US on getting ENERGY STAR ratings for ultra-low temperature freezers. So we had some experience in identifying or working with these types of eco-labels like ENERGY STAR. The problem with ENERGY STAR is that it only goes so far. So ENERGY STAR, of course, only looks at the energy consumption of a product. It doesn't look at the impact of its manufacturing. It doesn't look at the end-of-life impact. And it only looks at so it doesn't address chemicals and consumables, which are a big part of the waste production from a laboratory facility. So similar to what James spoke about with the Declare label, we saw a need for a nutrition label for laboratory products. And the Declare program is incredibly robust, and it goes much further than what the life sciences industry was able to start with. So what we developed is somewhere between what we have now, which is no information whatsoever, and full disclosure that's required by the Declare label. and this is called ACT. It stands for Accountability, Consistency, and Transparency. It should look very familiar because it's designed to look like a nutrition label. I go through each one of these in turn, but just to kind of give you a broad overview, you can see that it's broken down into manufacturing. So we look at 5 different aspects of manufacturing of the product, as well as the use phase and the end of life of a product and its packaging. So the packaging is incredibly important for the products that are purchased by scientists. And we want to make sure that we capture that impact on this label. You'll notice that there are numbers next to all of these. Everything except energy and water consumption is based on a scale of 1 to 10, where 10 is lowest environmental impact, 1 is the lowest environmental impact, and 10 is the greatest environmental impact. Notice that I'm not saying good or bad. These are not value judgments. They're just simply what it is. Energy and water are reported as actual values. So energy is reported in kilowatt hours per day. Water consumption is currently reported in gallons per day for the US label. We add up all of these scores to get a total environmental impact factor score, which is shown here on the bottom. Hopefully you can see my cursor here. The way that we tend to look at these labels is similar to a nutrition label. If you want to understand what the total environmental impact score of a product is, you can look at this final number here. If you're more interested in understanding what happens to the packaging at end of life because you have a waste diversion goal, you can simply look at that metric here. So just like a nutrition label, it allows you to compare products on the basis of what you think is most important and most valuable for your own particular situation. All of the labels are valid for 2 years and they have an expiration date. The process is quite simple in theory. The manufacturer provides documentation to a third-party auditor called Sustainability Made Simple. They are one of the premier auditing companies in the United States for this type of work. They do a lot of work with the International Living Future Institute. They also work with the USGBC and LEED, so they're quite well known. They audit all of that material. We verify what their findings are, and then the label is issued after we've spoken with the manufacturers. So just to briefly go through what this covers, the manufacturing piece looks at, has the manufacturing facility done anything to reduce energy, water, or waste in the last 5 years? And furthermore, are they using renewables? So you could see on the label there was this kind of a sub-piece underneath manufacturing that was just a yes or no, is renewable energy used at this facility. So again, this helps you make a decision about if it's important to you to purchase products that are made from renewable sources, then you can immediately see whether this product meets that criteria or does not. Responsible chemical management looks at the chemistry of the product, so whether this is a piece of equipment or whether this is actually just a chemical. We look to see what is the chemical composition up to 95% by weight. And we also look to see how that chemistry is managed throughout the supply chain and throughout the manufacturing process to ensure the health and well-being of the people who are involved in manufacturing that particular product. This is assessed by looking at SDSs typically and chemical abstract numbers or CAS numbers. In order to assess whether they are mutagens, carcinogens, reproductive toxins, things like that. This has been incredibly illuminating, I think, for myself as a scientist, because many of the products that I used, I had no idea what was in them. Obviously, the chemicals, you know what's in the chemicals, but if you're using xylene, you know it's xylene. But if you're using, say, a conical tube, or if you're using an autoclave, I would have no idea what was actually in those products. So I think from the perspective of scientists, this is also incredibly interesting to actually start to get at what is in the products that we're using and what are we being exposed to that we might not have realized were exposure hazards in the past. Shipping impact looks at the impact of shipping the product from the site of manufacturing to the site of distribution. The product content looks to see what is product made of and does it contain any renewable, bio-based, sustainable content. We look at the same for packaging. Does the packaging contain any sustainable content such as recycled content or bio-based content? And that rounds out sort of the beginning phase of the label, so the manufacturing piece. Now the product is in the laboratory space. We want to understand what is its energy consumption. And again, we report this as kilowatt hours per day because we know that this is what people are used to looking at and comparing products. It also allows universities or organizations to provide incentives to people who purchase energy efficient equipment on the basis of what the savings are. So as an example, Eversource, which is a utility company based in Massachusetts, they are providing rebates to customers on the basis of the ACT label by just looking at what the energy consumption is and what the difference is from an energy efficient product versus a standard product. The same is true with water consumption. This is reported as a per day number. We have a protocol that manufacturers must follow to test their products in order to receive this information. So this is not a manufacturer gets to tell us this is how much it uses under their incredibly specific conditions. So this is us specifying a protocol saying this is how we want it to be tested. We want to see that the meters are calibrated. We want verified information that this is how much your product uses under these standard conditions. And then finally, in the use phase, we look at how durable the product is. So how long is it meant to last? I think this is incredibly important, particularly for equipment in laboratory spaces, because you see more and more equipment having electrical components or components, computer components that require software. And a lot of times the hardware might be warranted to last for 10 years or has been shown to last for 10 years, but in fact the software is not designed to be upgradable for that long. So this provides, I think, some really good insight for scientists to understand what it is that they're purchasing and how long it's meant to last. And finally, end of life, what happens to the product and its packaging at the end of life? Is it recyclable? And by recyclable, we mean recyclable in a majority of the recycling infrastructures, not recyclable in California. Is it compostable? Does the vendor have a take-back program for the packaging or the product? And again, this applies not just to products that scientists themselves purchase, but also to larger pieces of equipment that might be purchased as part of a design of a building. For example, autoclaves. There are some companies that will actually take back their autoclaves and reuse those materials, and others have no take-back program at all. And their materials tend to not be properly disposed of as a result of that. So in practice, I say we're turning the entire life sciences industry upside down on its head because, of course, as I mentioned at the beginning, this is brand new for our industry. With the exception of recently Energy Star labels for pieces of equipment, we really have not had any transparency into the environmental impact of laboratory products. And just the very introduction of the ACT label and people talking about the ACT label has caused the market to really start to shift in a direction towards sustainability, towards more transparency and disclosure, which is very exciting. We have ACT labels not only for the United States and Canada, which is the first one, but also for the UK and the EU. So we have expanded the program in the last 2 years beyond North America to Europe out of demand for this type of information. We have on our website information related to the product categories that I've already mentioned, consumables, chemicals, and equipment. And at the moment, we have over 120 products with the ACT label. By the end of August, we will have over 250 products. So there's a whole batch of products that are being certified now, and that will be hitting our website. Hopefully, I was hoping by the end of July, but just to be safe, we'll say the end of August. So there's a lot of products and there's a lot of momentum. Here are some of the companies. So if you have a project or if you're a scientist who's listening and you're interested in this, here are the companies now that currently have ACT label products. You can see they range from some of the largest in our industry, such as Thermo Fisher Scientific and Miele, and Eppendorf, of course, and MilliporeSigma, to some of the smaller companies like Cooled, Micronic, and Chart. So it really runs the gamut of different types of products, and you can see examples of those products shown here on the right, everything from pieces of equipment to consumables to chemicals. Just to give you an example here, I'm going to have to move this over so I can see. Sorry, my control panel was literally in place of the label, so I couldn't read it. To give you an example of something that I know everybody on this call is probably familiar with, here's a label for an Eppendorf freezer. You can see here very quickly that manufacturing impact reduction is a 6, which means it's not a 10, so they haven't done nothing to reduce the environmental impact of their manufacturing. They've taken some steps. They do not use renewable energy. Responsible chemical management is a 1. So this freezer uses natural refrigerants. It does not contain anything that is considered to be hazardous or mutagen or reproductive toxin. And they manage their chemistry very well throughout the manufacturing process, which is why they receive a 1. You can see their product content is also a 1, which is interesting. Why is that? It's because this product is made of steel, and the steel that they're using contains, I think, over 70% recycled content. And so they're using mostly recycled content in this product. Their packaging content is a 5. A 5 is, obviously, they're not wholly recycled content, but not wholly virgin material as well. The energy consumption here on this freezer is a 10.5. This one was one of the very first ones we did. So the asterisk is showing that this was still needed to be validated. So I should probably update this because it has been validated since, and it's a 10.5. That's 10.5 kilowatt hours a day. The product does not consume water, so that's not applicable. You can see here again the packaging and the product for the end of life. The product end of life is an 8, which indicates that actually, in spite of the fact that it's made of steel, in spite of the fact that it probably could be recycled, in the absence of a take-back program, these products are actually not being properly disposed of, oftentimes by customers. The total environmental impact here is a 55. If you compare that to, say, an autoclave, which uses quite a bit more energy and quite a bit more water, you can see that the total environmental impact of an autoclave is greater. Now, these are not meant to be compared between different product types, but nevertheless, you can see that there's an internal logic and consistency to the labels, because an autoclave, of course, does, over its lifetime, have a larger environmental impact. In this case, you can see this autoclave here, again, made mostly of steel. Product content is a 1. Packaging content, this is a real opportunity for this company, and this is something that they've actually worked to address as a result of going through this process, to address their packaging to include more sustainable content. You can see their energy consumption, 31 kilowatt hours per day based on the cycles that we required, and water consumption of 76 gallons per day. Their end of life is a 1 for this product because they have a take-back program and they were able to demonstrate that they fully recycle and or reuse all of the components associated with this autoclave. All of the information that I'm sharing with you verbally might be something that you would want to know rather than just looking at the numbers. And so for that, we have on our website an explanation. So for anybody who's really curious about where the numbers come from, you can dive into this information on our website and actually look to see why did this autoclave receive, for example, the score that it did. As an example here, for energy consumption, we looked at 6 cycles in 12 hours, with 12 hours of the unit being in standby mode. So if you wanted to compare this autoclave to, say, another autoclave, this is the procedure that we used in order to determine the amount of energy that it consumed. Of course, the app label is most powerful when it's being compared with another product. So here's an example of actually the same product. This is a Miele glassware washer with 2 different cycles, the standard cycle and the mini cycle. And I just chose this as an example because it really just focuses on the only difference between the 2, which is energy and water consumption as a result of changing the cycle. Again, you can see that the standard cycle uses 1.5 kilowatt hours of energy and 11.1 gallons of water based on 1 cycle plus standby mode. And the mini cycle is about 30% less in both cases, 20 to 30% less. So this gives you the information you would need in order to make a decision about which cycle you would want to use. You would use the exact same type of strategy and approaching the product if you were looking at 2 different types of products. The label itself has been obviously used by quite a few manufacturers, but it's also been adopted by a number of organizations. These universities here were recognized by the International Institute for Sustainable Laboratories last year at their conference as being leaders in adopting the ACT label and sustainable procurement. You can see we have only one at the moment from Canada, so hopefully this inspires more people to become part of the program, but quite a few from the states, including Harvard, MIT, the University of California system, the University of Georgia, the University of Virginia, and others. And what these organizations have done is to actually include, in many cases, the ACT label in their RFPs, in their requests to procurement, or to vendors rather, for what they actually want to purchase. And this is on the scientist side. But the amazing thing that we have also done with this label is that I've been kind of alluding to here, is that we want to align this with the building space. So the ACT label forms a bridge with the Living Building Challenge to be able to take Living Building Challenge projects that are laboratory or healthcare projects and identify products that meet the materials requirements without them having to go through the declare label yet. So any laboratory life science product that has an ACT label can be considered for an LBC or Living Building Challenge project. And that's incredibly exciting because the life sciences industry was not yet ready to go all the way to declare, but we've helped to provide them with a stepping stone so that they can get there. And we've also helped facilitate it so that Living Building Challenge projects can identify materials, pieces of equipment, things that can go into the space that meet the requirements of that challenge. And that for us is very exciting because as I said, forming that bridge is going to be critically important for us to actually move the needle in these types of spaces. This disconnect has gone on for far too long and has really, I think, caused our organizations like My Green Lab, ILFI, I2SL, SL Canada to sometimes be divergent when we really could be much more convergent in our approach. One of the exciting things about this space is that it's massive. And to give you a sense of the scale of the impact that this could have if we all work together to help manufacturers obtain ACT labels, to request them for any building products that you might have, if you're a scientist, to request them for any products that you might be purchasing, is that if we were to just divert 2% of that plastic waste that I talked about, so if just 2% of that were to be diverted, either because people are now informed about what to do with those materials, manufacturers have designed those materials better so that they're meant to be recycled and can be diverted, just 2%, it would be the equivalent of reducing the emissions produced by it would be the equivalent to offsetting the carbon emissions associated with 5 million Americans. I think that's the best way to say it. It's 100 million tons of metric tons of CO2 equivalent, but 5 million Americans. I like to point out that it's Americans because we are really the worst when it comes to CO2 production and emissions. It's also the equivalent of 100 million acres of rainforest, just 2%. So this is the impact that we can have together on a program like this. And you can imagine that if we then marry this program with the work that's being done at the International Living Future Institute and their Living Building Challenge and their Declare label with our certification and our ACT label, you can start to see what kind of impact we can really have on the planet and how tremendous that can really be. So it's an incredibly exciting time for us to be working together and for us to be speaking to you about this. So with that, I'm going to hand it over to James. James, did that work? Yes. James, if you're speaking, we can't hear you.
Can you hear me now?
Yes.
Okay. Well, thank you, Allison. That's awesome, and I really appreciate you sort of setting the stage for the critical importance of the life sciences industry. It's such a massive energy and water consumer, and I think in the green building world is not an industry that has been as effectively addressed as it really needs to be if we're going to actually meet our climate targets and start to shift the building industry the way that we believe is necessary to meet Paris Climate Agreement targets, as well as to tackle key issues like toxics and water consumption, et cetera. So to kind of pivot from that, I want to talk about what we've found from building owners, the value of pursuing certification is. And we have 4 value propositions that we've identified. First is proven performance. The second is industry recognition. Investment in the future is the third, and the fourth is prioritizing people. And I think that's kind of a key one that I want to end on today. So proven performance, the Living Building Challenge, as I mentioned before, is the only independent performance-based verified green building standard. And so we're finding that our buildings use 75 to 90% less energy than standard construction. And I think one of the key parts about laboratory spaces and why it's so exciting to partner with Allison's organization is you're not going to get there through the building design alone in a laboratory space. You're actually going to have to start looking at the equipment and making better selections about how that equipment is designed and starting to change behavior about how people are operating within the building. And by requiring a specific target and proven performance, you can actually push towards those operational changes that often get lost in a green building certification that's just focused on design. Next is industry recognition. You know, for a university or a biotech company, building a living building is a way to ensure that your project is recognized as one of the leading green building projects in the world. And we partner then to share that story with the world. 40% of AIA Committee on the Environment top 10 winners are living buildings. They're regularly selected by World Architecture News as the greenest buildings in the world and garner tons of press and attention. Some of the few buildings that get written up in New York Times or have CNN documentaries about them. And we're also finding that building a living building, while likely having some initial upfront cost, significantly pays off in the long term and provide long-term financial benefits for owners. And you know, I think if you look at the price difference between a living building and standard commercial construction, we have about a 10 to 20% price increase, but living buildings are priced about the same price point as many buildings, many institutional projects. So it's possible that a living building could have a similar price point. However, you might be investing a little bit more in your solar panels or renewable energy and management system than you will in design features. And as I mentioned before, one of the key reasons people have recently been pursuing our program and key clients like Google is the spaces are just better for occupants. And companies know they provide the best space for their occupants, then they're going to attract and retain top talent. So I just want to mention a couple other things about why living building design actually can benefit human and environmental health, or actually, sorry, focusing specifically on human health. You know, designing a building that provides access to daylight, ventilation, nature can actually reduce stress, lower blood pressure, it can reduce depression, and it can boost mood, self-esteem. It can promote healing. For example, in hospital spaces, just having a window can ensure that you have 30% less pain medication, shorter stays. And this research is really becoming clear. There was a recent study done by Harvard called the Harvard Cognitive Effects Study that having better ventilation can have a dramatic impact on your mental performance. 26% 6% higher cognitive function scores, 25% higher sleep quality, 8% increase in decision-making performance. And I think about this applied to a lab space where the functioning and the performance, the happiness, the retention of high-quality scientists and researchers is so critical to the outcomes. And many of those spaces are not great spaces to be in. So the more that we can improve the quality of those spaces, the better the outputs from that research can be. So I just want to end on this slide to reinforce what Allison mentioned. What we're developing with My Green Lab is a partnership with a big mission and a big ambition to transform the life science industry. And what we realized working with her is what happens inside your building matters just as much as the building itself. So I want you guys to imagine, what if you all worked in living buildings filled with green labs, healthy, sustainable labs, and the most efficient, most sustainable, healthiest products. And we think that's a better way to do science. So with that, I think we're going to open it up for questions.
Great. It's Martin here again. Thanks, everyone. And thank you, James and Allison. It's an eye-opener, and I think just indicative of what some awareness can do to actually lead to some meaningful change. Let's just see what we have here in terms of comments and questions. And I guess the first is just a comment from one of the participants that what you're doing is such a need of the hour, and I can second that. It certainly is. We appreciate what your efforts are leading to. Let's see, we have another question here. Do you see these programs, the Living Building Challenge and the product label, being adopted by regulatory bodies?
Yeah, I can mention Living Building first, and then maybe Allison, you could go next, or Living Building Challenge and Declare. So Living Building Challenge has many incentive programs that have been in place. So for example, the city of Seattle gives you additional height and floor area ratio bonus. And we're starting to see aspects of the Living Building Challenge like zero energy make its way into legislation in states like California. So I think it is something that will increasingly be adopted legislatively because we're really pushing at the front end of the market. However, that's not necessarily our goal right now. We're really just trying to show that it's possible. And then when we have a critical mass of projects, that's when we can start to get some regulatory movement. It's interesting looking at the Declare label. The Declare label really aligns with REACH legislation. That's very common in the EU, that regulates chemicals in the EU. And so Europe is much out in front of the US, and that's being adopted by other regions around the world. Unfortunately, in the US, our Toxic Substances Control Act is very, very weak. And it's very unlikely that, at least in the short term, we're going to have any regulatory movement on requiring companies to disclose or remove toxic chemicals at the federal level. However, there has been some big wins at the state level, looking at children's toys and other consumer products. And there's certainly a big push from the market. And, our theory of market transformation is often you need those voluntary early adopters, and then when they start to scale, that's when we can start to push for regulatory changes. But you really need both. You got to demonstrate it's possible before you can get regulatory change.
Okay. Allison, I don't know if you want to comment on that one.
Oh, sure. So I think we're very much in the same position with, at least with the ACT label. I think there's a much greater chance that it will be a requirement, or at least built into sustainable purchasing guidelines in the UK and the EU before anything happens, at least in the US. I'd love to see if there were an opportunity for us to get it into sustainable procurement guidelines in Canada. The US is just going to lag behind at the moment for many reasons that shall remain unnamed. And the same with our certification. So our Green Lab certification, I think we're also looking to see how that can become a standard that is recognized and might be regulated outside of the U.S. It's similar to what James mentioned. It's not our goal, our goal is simply to change the culture of how science is done, and if it makes sense for it to be regulated in that way, it's fantastic. But that's not been our focus. Our focus is just getting out in front of everything and showing people the path forward and having people follow that path, come what may.
Okay. Thank you. Another question we have is, can you explain in more detail how the ACT label has been integrated into the Living Building Challenge requirements for laboratory projects?
James.
Yeah, so essentially with the Declare label doesn't really cover furniture, fixtures, and equipment or products that that the ACT label would address. And so what we've allowed within the Living Building Challenge is if a product has an ACT label and the building is pursuing Living Building Challenge, particularly the materials requirement, they're allowed to use that ACT label to demonstrate compliance. What we've also done is we've aligned the requirements within the red list with the ACT label itself at a bit lower percentages to recognize the complicated nature of the equipment that goes into laboratory spaces.
Okay. Let's see, another question here. When it comes to laboratory equipment, is the focus of the ACT label on products used by laboratories or project teams during the operation stage and not primarily during the detailed design or the construction stage of a lab?
That's a great question. So we are, at the moment, we have labels focused on the former, but we've just started conversations to address the latter. So we are not ourselves restricting where the label falls. It's just who has approached us with wanting to work with us on this program. So if you know somebody, or if you are somebody who is more in the design space and is looking at fixtures for the laboratory itself, we'd be more than happy to take those on board with the ACT label.
Oh, great. Another question, when it comes to chemicals and consumables, does this include consumables used by contractors during the construction of labs? I guess this is related to the label.
That's a really good question. So and this is actually a good question for James. So I don't know, nobody's ever asked me this before. James, are those covered by Declare well enough, or are those already covered by LBC in some other way?
Sorry, can you restate that? The
question was, when it comes to chemicals and consumables, does this include consumables used by contractors during the construction of a lab?
Oh yeah, so that's a great question. So yes, if they're products that are going to remain on the project. So I'm thinking like paint, coatings, sealants, etc. And then during operation of the building, we also have some requirements around green cleaning products, ensuring that they meet the design for environment requirements or an equivalent green cleaning protocol. So yeah, I'm trying to think of like what would be a consumable in construction that doesn't actually end up in the building itself. So, you know, it wouldn't cover like paint cans, for example, or the tubes of sealant. But Living Building Challenge itself has some strict requirements and requires sort of a nearly zero waste construction operation.
Okay. That's good. It's quite inclusive. Final question. How is My Green Lab working to increase the adoption of the ACT label and system?
Great question. So we've been working with leading companies and higher ed institutions to help them promote this to their scientists. I mean, the fastest way to get the ACT label program to expand is for people to use it and to ask for it. So we've been raising awareness by speaking. If you follow us on social media, you'll see that we've been all over the world in the last several months just talking about this label, giving webinars like this to help people become more aware of it. And then providing people with the tools to be able to integrate it into their e-procurement systems. That's really one of the best ways to help promote the adoption of this label quickly, so that when scientists search for products or when people in procurement have an RFP in front of them, they are aware of where to find this information, that a label exists, and that they should be asking for it. In addition to that, we've been publishing articles, issuing press releases, and relying on wonderful people like you to spread the word. Because this is how it's going to get adopted. Is really, I mean, this is how our certification started. Initially, it was just through word of mouth, and now it's a global certification with some of the world's largest companies certifying their labs. So that took 5 years. I'd like for the ACT label not to take that long. So let's have a concerted effort to try to spread the word, because I think the transformation that we can achieve here is just, it's really remarkable.
Yeah, I agree. I mean, the number you put up there at the end, the 2% reduction in waste, is that's staggering. I mean, 5 million people. That's a lot. And I think we should all be trying to do everything we can to improve our environment for the generations to come. So that's it for all the questions. So I guess on behalf of SLCan, I'd like to say thank you again to both of you, James and Allison. It was a terrific presentation and certainly raised our awareness of what your two organizations are up to. And I think there certainly is a place for it in the world. And I think that it's incumbent on all of us that are listening and participating today to go out and help raise awareness. So thank you.
Thank you. Thank you very much for having us. It was a pleasure.
Okay. Well, everyone take care, and with that, we'll sign off. Thank you.
Okay.
Thank you. Bye-bye.
Bye now.